Okay, last addition of ordinates example. We'll do this one nice and quick because we really get the vibe of all these now. They're very similar. So I've got my graph y equals x cubed plus 2 on x. I can see here that x is non-zero, so that automatically will be my vertical asymptote. I'm going to write this out split up as two things, and cancelling this down, this will be x squared plus 2 over x. Now I know that the shapes of these graphs are going to be a parabola and then also a hyperbola. So I'm just going to do those in different colours, blue and green. And we'll do those on a nice small graph just so we get the idea. I'm not even going to rule that one, just nice and quick. So we've got x squared and 2 on x, which is on this side, it's the positive quadrant, because you imagine the y equals x going that way is positive. So it goes through quadrant 1 and quadrant 3. So once you've got your basic shape going on, we now look at the shape of our addition of ordinates graph. I'm going to do that red. I know that I have an asymptote at 0 because x is non-zero, so there's an asymptote there. My intersects, there's one here, so that's going to be that distance times 2, so there's going to be a point there. Now I can see that as x goes to infinity, y starts to approach x squared. The reason for that is this term disappears. This starts to approach 0. So the graph will actually approach this as a type of asymptote. So that means that we have a non-vertical asymptote at y equals x, and we have a vertical asymptote at x equals 0. So I've put those both in red, and I'm just going to draw my graph in. So it has a sort of shape like that. Okay, this part here is a little bit more difficult to tell what's going on. Now, what's happening here is you can see that the graph starts to get really big here in the blue, but levels off to like 0 at this point here. So what that means is that you've actually got a graph that is going to get big here. Whoops. Because this is having less of an impact. But see here, the graph is 0 at this point, but it's getting really big here in the green. So the graph is actually going to, and I might just move this over so I can do this a bit easier, is going to be big here in the negative. It's going to get to a point here where the distance between each graph is the same, plus and minus. And that's where those graphs effectively cancel each other out and give you a 0 point or an intersect. So we're going to have an intersect there and then start to approach that graph. So you've got two different sides to this graph here, this part and then this part, and two important points. A turning point will be here and an intersection will be here. So our job now is to find those points. First thing, finding there's no y-intercept, but there is an x-intercept. So for the x-int, we need to look at what happens when y equals 0. So we've got 0 equals all of this, x cubed plus 2 on x, and that's easy because multiply both sides by x, just the top line remains, which means that x cubed equals negative 2, therefore, x, we'll write that again, x equals the cube root of negative 2. Now if you wanted to, you could actually write that, and I'm going to write that as negative 2 to the power of a third. You could also give that as an approximation, but I'm going to keep it exact. Okay, so x equals negative 2 to the power of a third is where we have an x-intercept. For our turning point, what we need to do is find our derivative and let that equal to 0. So we've got dy dx equals, the derivative of x squared is 2x. The derivative of 2 on x, 2 over x is 2x to the minus 1. So the derivative would be negative 2 x to the minus 2. And we're going to let all of that, that's 2 on x squared, equals 0. So we now have 2x equals 2 on x squared. Multiply both sides by x squared and actually cancel the 2's out. X cubed equals 0. And what you find then is that you end up with, equals 1, is that you end up with x equals the cube root of 1, and that's just going to be 1. All right, so, and I'm just going to make this a little bit clearer here just so you can see it as well. So x cubed equals 1 gives us x equals the cube root of 1, which is 1. So we have a turning point at 1, and we know that the function at 1, if we put 1 in here, we have 1 squared plus 2 on 1, well that's 3. So we know that that particular point, we have a turning point at 1, 3. So we've got our turning point and also our x-intercept, and I'll just label those there as well so you can see x-intercept and a turning point. I'll just put a box around them as well. There's quite a bit happening. All right, so our next job, now that we've got our x-intercept and our turning point, just move that over. Oops. Beautiful. Is to now do our final graph, because this graph is a little bit rough. So I'm just going to do my graph here. I know that I've got 2 asymptotes, so I'll just move this over. And I'm actually going to do my formal graph now. So I'll get rid of that one. So put in my axes. I know that I need a little bit at the top and a little bit at the bottom here, below the horizontal axis. X, Y. I know that I have a turning point at 1, 3, so I'm going to put some tick marks in. 1, 2, 1, 2, 3, 1, 2, 3. And I know that I have the graph y equals x squared as a, that should say x squared, as a non-vertical asymptote. And I know that that passes through 1, 1, and it also passes through 2, 4. So you can see I've put those points on the graph just to make my graph reasonably accurate. So that's my non-vertical asymptote y equals x squared. I also have my vertical asymptote at x equals 0. It's going to say vertical asymptote there. I then have my graph going through a turning point of 1, 3, which is there, and label that. And I know my graph approaches the asymptotes on each side. On this side, my graph will approach both asymptotes like a magnet. It'll be drawn in, but it also on the way through goes through this point, -2 to the power of a third. And just to approximate that, I'm just going to use my CAS. So I've got -2, oops, 2 to the power of 1/3. And all I want to do is just get an approximate on that. -1.2, so we can do that. So -1.2, it's sort of there, somewhere there. So we've got our point there at -2 to the power of a third, and our graph is approaching the asymptote, going through and then approaching the other asymptote. And I might just do that so you can actually see it has a nice curve to it, like that sort of curve. Let's move this back a bit. There we go. So 2 parts to the graph. This part here which is approaching your asymptotes, and then this part here which has the turning point inside those 2 asymptotes, the vertical and the non-vertical. So for your addition of ordinates of x cubed plus 2 on x, that's really just adding the 2 graphs together of x squared plus 2 on x to get this graph here that's shown in red.